thank you so much for joining us today. We've got Charlie Waddell, who's the founder, inventor, and CTO of Global Plasma Solutions with us. We're going to talk about their Needlepoint Bipolar Ionization technology and why we think it's so exciting. Charlie, would you mind starting just introducing yourself and letting us know what led you to this technology?
Sure. Hello, everybody. I'm Charlie Waddell, the founder and chief technical officer at Global Plasma Solutions. I've been in the HVAC industry for approximately 20 years. My background's electrical engineering out of college, and I used to work with a company that manufactured bipolar ionization, but I will say it was the older form that's been around for quite a long time, actually since the 1960s within the US itself. And I saw a need in the market to redevelop the technology, advance it, eliminating ozone and eliminating replacement parts. So I left that employer and founded Global Plasma Solutions as to use the technology as you see it today, and we call it Needlepoint Bipolar Ionization, or NPBI for short.
Cool, thanks. So could you tell us a bit about how it works, what exactly it's doing?
Sure. So our patented NPBI technology uses an electric charge to create a plasma field that's filled with high concentrations of positive and negative ions, which has been shown to be more effective than unipolar systems that will emit only negative or positive ions into the ductwork. As these ions travel with the airstream, they actually attach to pathogens, particles, and even gas molecules, rendering them ineffective or breaking them down depending on what you're starting with. These ions actually that are produced travel within the airstream into the occupied spaces of a building where they can help clean the air everywhere that these ions can travel.
Yeah, I'm sitting here in our innovation center right now where we actually have it installed. And it's really nice knowing that it's here and doing everything that it's doing. So where in an HVAC system does this get installed?
Generally, we like to mount this technology after the filters. It's very important to be after filters because any filter will stop the ions from flowing further downstream in the system. And so with our technology, we recommend after the filter and before the cooling coil so the ions can flow through the coil and sanitize your coil as well. So it's similar to having a UV light on the wet side of the coil to keep the coil clean, but instead of using that technology, this technology can do that for you. But in a lot of these systems, you may not be able to fit the technology between the filter and the coil, so we could recommend mounting it on the supplier fan inlet, which is a great application for our the FC24 or FC48. Or if it doesn't fit there quite well, you can put it on the supplier duct and use what we call our duct mount product, the DM48, which will also help increase the ion levels into the space because it's closer to the space.
Thanks. So how do you know that you're getting the correct product for your HVAC system?
Well, NPBI is customizable to any HVAC system, and it can match the system's existing CFM or their tonnage to ensure that the levels of ionization, as we typically measure in ions per cubic centimeter with handheld meters or duct mount type meters, will reach the effective levels that we want to achieve in order to help control pathogens, particles, and odors. The goal is actually to reach around 1,500 to 2,000 ions per cubic centimeter in the occupied space as a minimum. And GPS does make several types of NPBI products, so you can match the correct technology for the type of air handling system that you have and fit it in there properly, no matter if it's a small 2-ton system like a residential split, all the way up to a very custom large air handler that you would see in healthcare applications or even airports that could be 200, 300, 400 tons of air conditioning in one system. So we have a product that fits everything regardless of what size you're dealing with.
Thanks. What kind of maintenance is required on these?
Our technology requires very little maintenance. Some of the systems are what we call direct current or DC, and they have auto cleaning wiper blades built in that every 3 to 5 days, these wiper blades automatically kick into gear and they clean the brushes for you automatically. So there's truly no maintenance with the system and there's no replacement parts. We also have an AC type system or alternating current system we call the GPS iMod, and that system does not require self-cleaning wiper blades because AC does not have a static charge on it, and so therefore it stays clean a very long time. In addition, these devices are always mounted downstream of filters, so the filters take out the majority of the particles before they ever get to the device, so that helps to keep it clean. But we do recommend at least once per year when you change out your filters, take like a paintbrush or a nylon brush and just walk down the bar and wipe the bristles down to make sure that you are receiving the maximum levels of ions into the airstream.
Cool, thanks. That sounds very simple and easy to do. So we know this is going to be good for attacking things in the air. How do we know it's safe for us?
Well, there are several ways to know that it's safe for us. There's 2 thorough meta-studies that have assessed the safety of ionization, and I quote, air ions and respiratory function outcomes. A comprehensive review concludes that the reviewed human experimental studies do not indicate a significant detrimental effect of exposure to positive or negative air ions on respiratory measures. So there's a lot of studies out there that talk about the benefits actually of increased levels of ionization. And when you think about where these ions are occurring naturally, and that's the key, is they are already out there in the atmosphere. You go to a waterfall and you take air ion counts, you're going to see high levels of ions, generally around 20,000 ions per cubic centimeter. And as I mentioned earlier, we just want to get the levels up to 1,500 to 2,000 to have a positive impact for the indoors levels of the building, because your mechanical filters will actually rob the air of its ions. And so without our systems in your facilities, you generally will see around 100 to 500 ions per cubic centimeter. So what we're just trying to do with this technology is artificially recreate those nice environments and raise those ion levels up. And there is a lot of independent peer research data out there that proves the systems are safe and effective, with the caveat that you're not generating ozone as a byproduct with the technology, which of course our technology has been certified to be ozone free.
And how do you know it's ozone free? What does that certification look like?
So that certification is called UL 2998. And as a matter of fact, ASHRAE has now mandated for commercial buildings going forward since 2019 that any electronic air cleaning technology, whether it be a UV light, a polarized media filter, or a bipolar ionization type generator like we generate, they must be certified to UL 2998, specifically in ASHRAE Standard 62, Section 5.7.1. And what that test looks like is that you've got this chamber that's approximately 1,000 cubic feet. Generally, it's 12 feet long, 8 feet wide, and 10 feet tall. They will place your device inside of that chamber, and for 8 hours, they measure the ozone 2 inches away from the device. And at any point, if the ozone levels exceed 5 parts per billion, then you fail the test. And when you think about 5 parts per billion being the limit, that's extremely low, because most devices in your home that requires power put out more ozone than 5 ppb. And if you go outside and take measurements at most localities around the country, you're going to see 20 to 50 parts per billion of ozone outdoors. And so it is a very stringent test, but ASHRAE recognized it was very important, and they made it a part of the standard, because the traditional standard that electronic air cleaners are tested to, UL 867, did not even require ozone testing if the products were mounted on the duct. So that was a huge loophole in the previous standard, which now the new UL 2998 certification has leveled the playing field. So regardless if you're duct mounted or a portable room air cleaner, you have to be tested for ozone to be in accordance to the latest ASHRAE standards.
Very interesting, thank you. So beyond the UL certification, what other testing have you all done to prove an effectiveness?
We've done a lot of a substantial amount of testing with third parties actually on our needlepoint ionization technology. And these include EMSR laboratories, ALG laboratories, innovative bioanalysis, which is our most current testing that was actually specifically for COVID-19 and not just a surrogate like a lot of the other competitors have been testing to. We also have testing in space with actually third-party testing firms, industrial hygienists, and measuring the levels of ions in the space, the levels of particles, gases, and odors in the space, as well as pathogens. A lot of the hospitals that we've worked with over the years, they will go in and do pre and post testing in their operating rooms and show reductions in airborne viable bacteria, meaning it's still living and could infect you if it gets into that open wound. And they see tremendous reductions in particles, pathogens, and odors, in those applications.
Well, so getting to that, you mentioned being installed in hospital systems. Is this a new technology? Has it been installed very many places?
It's not new. The company's been around since 2008, and we have over 300,000 installations using this technology. And installations range from residential applications to commercial, schools, universities, including Johns Hopkins Medicine, Duke Health, Mayo Clinic, Boston Children's Hospital, Google's headquarters, Starbucks headquarters, Harvard University. A lot of people, even including the White House have used this technology. So it's been well vetted by the General Services Administration, the GSA, for installation into the White House. They specified it instead of using UV lights on the most recent upgrade to the HVAC systems in the White House. It's also been certified by the FAA because this is the only technology that's been certified to be installed onto aircraft because it does not produce line noise, EMF, or ozone. So now passenger airplanes can use this technology to help reduce particles and pathogens in the cabins as well.
That's all really impressive. So how will this impact the performance of the rest of my HVAC system?
Depends on which product you use and how you mount it. But and as an example, you use our GPS iMod, mount it to the air inlet side of your cooling coil, the plasma flows through the coil and it keeps the coil clean. And so that will reduce the load on your cooling system, your chiller plant. It will also reduce the load on your fan because the fan has to work not quite as hard. If the biofilm that tends to grow on the coil does not grow, or you kill it and it goes away, you open up the passageway for the air to flow through the coil. And so at that point, the pressure drop goes down. So you not only save energy at the chiller, you save energy in the fan motor because the fan's not working as hard to move the same amount of air. And a lot of people have actually benefited, especially hospitals that have older systems, really deep coils for dehumidification, especially in the South, that will reduce the pressure drop by 2 to 3 inches of water column through the coil. So that's a significant energy savings plus chiller savings by cleaning the coil. The other huge benefit to the technology and enhancing other products in the system are specifically the filters. There's a lot of independent data that shows our technology combined with a MERV 8 filter will give you MERV 13 effectiveness. One of the things that the ASHRAE task force has recommended for COVID-19 is increase your filter efficiency in your system. However, ASHRAE said if you cannot increase your filter efficiency, you can use ionization to help supplement the filters and increase their filter effectiveness. We also have testing from the National Research Council of Canada on an actual installation showing that a MERV 12 filter acted like a MERV 16 filter. So we're getting that huge filter reduction or filter efficiency without the impact of the higher pressure drop of the actual higher efficiency filter.
Interesting, thank you. How will your technology enhance other parts of infection prevention and control, such as PPE?
I don't think you should make any changes to your existing infection prevention and control processes. Follow your state and government guidelines, whatever they're telling you to do. This is just a supplemental technology that's not intended to take the place of other reasonable precautions out there and in the transmission of the virus or other types of pathogens. It's important to comply with all of your public health laws and guidelines. We've always stated that. We don't want to tell you that this is the silver bullet. You put in this technology and you don't have to wear a mask and you don't have to do that. We still recommend wearing the mask, wearing the PPE and the applicable applications and healthcare applications. And it's a holistic approach. This is just one tool in your bag of offerings to make sure that you are controlling the contaminants in the space, in the duct with this technology, but is not meant to replace these other government entities, regulations or suggestions for helping to prevent the transmission of the virus in the first place.
Cool, thanks. So how does your technology compare to other kinds of bipolar ionization that might be out there?
Well, there are quite a few other competitors out there. A lot of our competitors still manufacture this technology, what I call the best way the 1960s had to offer. They use glass tubes, or they use composite tubes, or they use mica tubes in order to generate the ionization, but it's a very energy inefficient process, and also it's not solid state. You have this tube that actually wears out and has to be replaced. And because the voltage has to break down literally the dielectric of the tube in order to complete the electrical circuit, you get ozone as a byproduct because the power level it takes to break down that tube is going to exceed the level for oxygen. And when you ionize oxygen, you always get ozone as a byproduct. Now, while you can try to limit the amount of ozone with those types of systems by controlling the voltage to just the point where the tube's conducting, it still generates that corona discharge, which is going to generate ozone as a byproduct. And so the way to prove the systems are safe and effective, regardless if you're talking about global plasma system or our competition, is ask for their UL 2998 certification. I don't know of any manufacturer that makes glass tubes that could possibly pass that based on my experience, I came from that industry. I have personal experience, and I don't know of any system and any method you could possibly produce ions with a glass tube system or a composite tube system without the formation of ozone as a byproduct that would still be below that 5 parts per billion threshold. The other thing to keep in mind is the levels of ions between a needlepoint system and a corona discharge system is greatly different. With a glass tube system, you can have anywhere from 200,000 to 800,000 ions per cubic centimeter generated on a 20-inch long tube. Compare that to one needlepoint brush that has maybe over 1,000 individual carbon fiber brushes in that cluster. You could generate over 200 million or 400 million ions per cc from a needlepoint system. And because there is no dielectric, we can control the power levels to a lower level. We don't ionize oxygen, and we don't generate the ozone. So that's how we achieve the high ion output, but without the formation of ozone as compared to these other technologies that are in the market.
Cool, thank you. So similar question, how does your technology compare to UVC systems?
Well, UVC, and assuming it's just a UV light with no other type of catalytic process along with it, like titanium dioxide, UVC mounts generally in the HVAC ductwork, and most times it's over the drain pan of the cooling coil to shine on the wet side of the coil where you get the biofilm and the mold growing, because you've got a dark environment, there's no light, it's wet, and as soon as you have particles coming through the air, that's a food source. So it's a great breeding ground for mold to grow and biofilm to grow. So that's where UV lights are normally mounted, and they do a great job at killing what they can shine on. But the problem with UV light is that that's the limitation. The particles or the virus has to get back to that cooling coil and in front of that light, and you've got to have enough light output. The microwatt density has to be high enough, and you have to have enough time, residence time, in front of that light for the organism to be killed if you're thinking about trying to kill on the fly. With our technology, you can mount it in the ductwork as well, but where the plasma is generated, those ions travel with the airflow, so you have the residence times the entire length of the duct, and then even onward out into the space. And so we are controlling contaminants and pathogens, not just where they're mounted in the ductwork like a UVC light, but also downstream and into the space. UVC will also not reduce particles, and it also does not control gases and odors. But if you do combine UV light with a titanium catalyst, you can look at some odor reduction, but science and actually research from ASHRAE has shown that there's byproducts through that process called photocatalytic oxidation process. And the research project was 1457 by ASHRAE, if you want to take the time to look that up. And it did show byproducts. Actually, there were gases leaving the system that were worse than the gases entering the system, as well as there was so much ozone from multiple products that were tested in this lab at this university doing this testing for ASHRAE. They actually had to evacuate the lab multiple times because of the ozone that was formed in that PCO process. So that's something to look out for. I know that there are advances in that technology coming that will help reduce the ozone. But as of right now, what I've seen and what I've tested and what I've read, there are high levels of ozone with PCO technology. But head to head, the UV light, there's no replacement parts with our technology. There's essentially no maintenance depending on which product you buy from us. With UV lights, you've got to replace the lamps every year. There's mercury in those lamps, so it's a biohazard type disposal. You need to dispose of them properly. You cannot just toss them into your garbage in most jurisdictions. So that's also something to think about with UV light.
How could this technology enhance something like personal protective equipment?
There's several ways we can help enhance PPE. One of the things, face masks. There's independent research from the University of Cincinnati that shows that by ionizing the air in the space, it makes face masks more efficient. From my memory, I recall that even an N95 respirator became 48% more efficient. A surgical mask became over 198% more efficient. A mask that like you would wear in a wood shop became over 3,000% more efficient. So bottom line, the lower the efficiency of the material in the mask, the more impact the ionization in the space will have on that material. So it helps increase the effectiveness of the face mask itself by ionizing the air in the space. The other benefit to PPE in this technology is that it does neutralize and reduce static electricity. And static electricity has been shown to cause problems in quality control and semiconductor manufacturing, as well as even medical device manufacturing. And because things become statically charged, they actually pull the dust out of the air, especially the ultrafine particles. And that's the size where COVID-19 and these other bacteria and molds reside, or in that ultrafine space. And so by ionizing the air with both positive and negative ions into the space, you can help neutralize the charges on the PPE gear, because as you wear plastic around, plastic will charge up on the surface, and you want to reduce those static space charges. So those are the two areas I see this technology could impact with PPE gear: is face mask enhancement and reduction of static on their clothing as well.
Interesting. Well, that's all the questions that we were going to highlight in particular. Was there anything else that you were wanting to add or make sure got covered?
No, I think you asked a lot of great questions here, and that covers a lot of what I actually hear often from a frequently asked question basis. I would just say, do your homework. If you're looking at other technologies, ask for the ozone reports, look at what their ion outputs are, ask them if they can guarantee you hit the minimum levels of ions in the space, and ask for what type of third-party data they can offer you to prove that their technology has been tested against COVID-19, or what surrogate did they test against because they could not get COVID-19. So try to get a comparison, apples to apples, when you're looking at other technologies, if you look at other technologies.
Cool. Well, Charlie, thank you so much for your time today and your help with all these questions. This was very informative, and thanks for your time.
You're welcome.